Okay, in this video we're going to talk about chemical reactions and the process of balancing such reactions. So let's first start by defining what a reaction is. First, we're going to have components on the left side of an arrow, which are known as the reactants. And we're going to have components to the right side of the equation that we call products. Much like you read a book, you read a chemical equation from left to right. And as I said before, A and B, the big things here represent reactants. They could be molecules or they could be atoms. The products also are depicted here on the right side, and they could be molecules or they could be atoms, depending on the reaction itself. The little letters here preceding the molecules are known as the balancing coefficients, and they do ensure that you do have the same number of atoms on both reactant and product side of the equations. In addition to that, we're also going to be including the physical states of the molecules or atoms in question. In some cases, we might use the subscript S, or the subscript L, or the subscript G, or the subscript AQ. Each one of them stand for solid, liquid, gas, or aqueous respectively, and do tell you about the state in which the particular molecule is present, at least at the experimental conditions for the setup. When it comes down to solutions, which we've talked about a little bit, uh, in terms of water, there's plenty of things that can be dissolved in it. You could have solids dissolved in water, such as salt, sugar, or you could dissolve liquids in water, like alcohol or vinegar. Those are your liquid solutions for which we talked about percent mass by volume or even volume by volume in terms of concentration. We could also have gases dissolving water, and that will be a topic that we'll talk about later on. Okay, but any substance that can be dissolved in water can have this subscript AQ, meaning that you have dissolved in water. You have a solution with water. Now, to be more specific, let me show you an example where we're going to balance the equation. Here we have CH4 reacting with Cl2. In the process, we do form CCl4 and HCl. Now, our task is to ensure that the number of atoms on both sides of the equations remain constant, because if they do not, we have violated the conservation of mass, and that cannot happen. So here we go. Now, the way you do this by inspection is by looking at elements within the molecules, and the idea is that you want to have an element, like if you focus on carbons, for instance, you want to have an element that's only present on one molecule on the reactant side and only one molecule on the product side. Carbon fits that profile because it's present only once in CH4 on the left side and only in CCl4 on the product side. Hydrogen also fits that profile in this equation because we have hydrogen in CH4 and we have hydrogen in HCl, only present once per side of the equation. Chlorine, on the other hand, is present in one molecule on the left side, but two molecules on the right side. And because of that, you actually want to leave chlorine until the very end as far as balancing goes. You don't want to start with chlorine because it's present in more than two molecules. So you will leave that till the end. You will first focus on the atoms that are present only in one molecule per side. So looking at carbon, we have one carbon on the left side, we have one carbon on the right side. That is balanced. You don't need to do anything there. Looking at hydrogen, we have four hydrogens on the left side, and we only have one hydrogen on the right side. So we will balance the equation by placing a coefficient of 4 in front of HCl. That balances the number of hydrogens on both sides of the equation. Now the thing though is that when you place a coefficient in front of a molecule, not only do you change the amount of the specific atom that you're trying to change, but you do change every single atom present in that molecule. So now the amount of Cl has gone up. Specifically, you have 4 Cl's coming from CCl4, but now you have 4 Cls coming from all the HCl molecules. So you have a total of 8 Cl atoms on the right side of the equation, which means that in order to balance the chlorines, we're going to have to place a 4 in front of Cl2 to fully balance the equation. And this is how you balance the equation by inspection.